starting on the basics on slide 2, what is Lifeline? And on page 3, I think the 2 main bullets that kind of sum up in a very high-level summary what Lifeline is. The first is high availability across sites and to reduce unplanned outages, but also, the second bullet, facilitating planned outages in a way that has much less downtime than is usually experienced by customers today. On slide 4, the reason that I really like this chart, and this is the results of a survey that IBM did that surveyed thousands of customers, is not to scare you with big numbers. I think all of us understand that downtime can have a really significant impact on a company in many different ways, from brand and productivity and reputation and a lot of different factors. But what I think is really interesting about this chart is the dramatic difference between a minor disruption and a major disruption. And so this informs us that, sometimes the perfect can be the enemy of the good. And I think this chart informs us that if we target a strategy that turns major disruptions into minor disruptions, something that's a few seconds or a few minutes, it still has an impact, but is a dramatically lower impact than something that is a couple hours or longer. And so I think that's an important point. The other thing that I think we often talk about numbers and costs, but page 5 goes into some of the things that are not directly financial impacts, that are often actually long-term, the more meaningful and more important impacts to a company during an outage. Speaks to their viability in the marketplace. When I was on the customer side, because of the nature of our business and who we served, some of the largest banks in America, it was a corporate viability issue, right? Do we have a valid business model if we can't be a trusted business partner? It was that serious. And on page 6, I think the importance of this chart for me is to remind us all that it is not a hard drive crash that is often the case, that is often the root cause for an outage, for a system outage. Hardware failures are not really all that we're targeting anymore. I think it's really interesting when we look at human error in particular, the perception by customers when surveyed what the impact would be to them if there was an outage due to human error. They rated that number 5 out of 6, one of the lowest impacts, when in fact it was the most significant impact to their reputation if there was an outage due to human error. And so there is a mismatch between what companies think they're at risk for and what will impact them in the marketplace from an outage perspective, and what we see in reality. So, just at the beginning of the presentation on slide 7, I'm trying to connect this to how this might be relevant. Some core problems that we're trying to solve. If site outages means that there's going to be critical workloads that are down for hours while secondary site IPLs. If you're tired of your system being down during regular maintenance windows, right? Because the time it takes to IPL and switch as part of that maintenance operation if it's a Sysplex-wide upgrade. And if you're frustrated that a secondary site is sitting there cold because you're using Displaced Replication, those are areas that we're intending to solve. So on page 8, Lifeline enables near zero downtime for critical workloads during unplanned workload or site-level outages. So this is not just HA within a Sysplex, this is across your sites. Lifeline helps reduce planned outage downtime for critical workloads from hours to minutes. That's actually been one of the more important use cases that's pushing people to adopt Lifeline. It's not the what happens when something goes wrong in production, it's the I know that I'm going to incur outages for thousands of users or business partners during this planned outage time. Is there any way that I can get that window smaller? And I think on the third point, a key thing to indicate here is that when we're talking about HA across sites, unlike a metro mirror-based solution, we have no geographic limitations. Slide 9 just kind of level sets what I think most of the people on the call are already going to be very familiar with, which is the other solutions in the market today. And I'm not going to read through the whole thing. I'm just going to point out most of what we're looking at here are disk-based replication solutions, right? Which when you're looking at a GDPS hyperswap and a Metromirror solution with two data centers very close together, that can be a good story. With synchronous data replication, no data loss, the ability to switch over. But especially as we look at XRC, where we're already assuming asynchronous data replication, it's a much less ideal story, right? So we still have asynchronous data replication to a site that's too far away for synchronous data replication. But we're not getting the advantages of what a higher level replication strategy might have, where the system's on and running. The system's still often cold. You still need to incur an IPL if you switch over. And that really, I think that pink column is the most immediate sweet spot where it's almost a no-brainer. For customers that are using XRC today, Lifeline is a vastly better solution. And I think for the other columns, it's going to be a case-by-case basis that we would evaluate to figure out if Lifeline is a better fit than what you have today. I think oftentimes it will be. So on slide 10, a couple other key differentiators. A disk-based replication, kind of by its nature, is whole box. So you're applying the same rigor and the same strategies and the same recovery time objectives to your batch processes that work once a month and your critical tier 1 workload that hurts when it goes down for 30 seconds. Most businesses don't work that way. Most CIOs are not willing to pay the same amount to recover a batch process that works once a month versus their major claim system that's processing their core business. But it's a very coarse-grained, broad brush that most disk-based replication strategies pursue today. Lifeline is different. Lifeline is a per-workload solution. That means it can be much more incrementally deployed. You don't have to bite off a long, multi-year, complex, risky project to do everything in one fell swoop. Instead, you can target just your most important workloads one at a time and apply Lifeline just to those workloads to get high availability and almost zero downtime across sites for that workload. So that allows you to incrementally show progress to your business as you pursue your strategy, instead of saying, just trust me, I'll come back in a couple years and everything's going to be awesome. Instead, you can show incremental progress over time as you tackle your most important workloads and get them to a higher level of availability for your organization. The second bullet is a feature that we call active query. For some workloads, even for the same workload, you can have that same workload active on two sites at the same time, and get more value out of your secondary site investment that way. Even without active query, you can still have both sites running active workloads, and we'll get into that a little bit later. But using active query, you can actually have both sites active for the same workload, with some caveats that I'll get into. Like I said, on slide 11, no disk-based replication, no geographic distance limitations. Sometimes people are funny about this one. I don't mean Mars, but on planet Earth, there's no distance limitation, and it's relatively low impact from an implementation perspective. No configuration changes to applications, clients, servers, or the network topology. On slide 12, this is here for your reference later. I think the one that I really wanted to point out was at the bottom. When we talk about DR strategies, that last one, verification of disaster recovery procedures, a lot of organizations struggle to prove that their DR procedures work, or they pursue it at significant cost to the organization. I think one of the things that we've seen be very valuable to our customers is that Lifeline enables them to validate and verify their disaster recovery procedures in a way that is much less costly to the organization, which makes it much more achievable for them to get to higher levels of certainty that their DR procedures are going to work. So that's a game changer for some of our clients. On page 14, I'm going to be very brief here. I think everybody on the call these are basics that everybody understands very well, but just to level set, of course, DR is recovery to a secondary site in the event of a significant outage or disaster. Continuous availability oftentimes is talked about within a data center, within a sysplex, within a cluster of machines. We'll be talking about continuous availability across sites with unlimited distance. And these two are more important for us to talk about, recovery time objective and recovery point objective. So recovery time objective is really the core problem that Lifeline is trying to solve. In a disk-based replication strategy where the secondary site is cold and you're replicating to disk underneath it, that IPL, especially if DB2 has to go through and reconcile a bunch of records during an outage, can take quite a bit of time. And in a Lifeline scenario, because both sites are already up and running, they're already IPL'd, they're already ready to go, basically you're just waiting for the replication queue to flush, and in a planned outage scenario, the primary system to acquiesce before you can switch over. In a unplanned outage, the switchover is quicker because that acquiesce is forced. And then recovery point objective. This is the amount of data that is lost during an outage. So, and this is probably the most important trade-off for me to be clear about, just so that you guys, just in an effort to preserve integrity, the thing that is an additional risk that you take on with Lifeline if you are using PPRC or another synchronous disk-based replication strategy today, which only works when your data centers are very close together, is that by going to asynchronous replication, you do accept the risk of some data loss, meaning if there are, for a lot of our customers, the queue never gets above a second or two, but if however many seconds of data are in that replication queue, when there is a catastrophic outage, whatever hasn't been replicated in the queue is potentially lost data. And at least it's going to take a while to recover that once the tapes or whatever else from the primary system are brought back. So the recovery point objective is a trade-off when you're going from PPRC to a Lifeline-based strategy. If you're already using XRC today because your data centers are 50 or more miles apart, then you're already accepting the risk of asynchronous data replication because that's asynchronous as well. So I think slide 15 I can skip, went into data replication enough, and 16 as well. So so I'm going to jump right to 18. So Lifeline can be and is sold on its own independently and also as part of our GDPS solution. So if you guys have heard about GDPS active-active, Lifeline is the core component that makes that work. But it only depends on a very few components. It is not dependent on the GDPS solution or the full suite. It requires disk-based replication, so QRep, for instance, if you're using DB2. And for active query to work, it requires NetView. And we also require for you to have a router that complies to the open industry standards that we use to inform that router and advise it, such as an F5. F5 is probably the biggest one in the market that supports that standard. Those are really the components that you need for Lifeline to work, and that's it. The rest of the GDPS solution is not required. And so for customers that are looking to make progress on an active-active solution, but the full GDPS solution is maybe a little too long or complex to get funding approval, you can start with a much smaller, much easier to swallow Lifeline-based strategy and then grow to a full GDPS solution over time. And because we are the component within GDPS that's enabling that active-active site capability, you're not choosing one path, then you're going to have to do some rework to go down the other path later. It's an onion strategy where the work you do now will be compatible with adding the complexity of GDPS later. And so we think that an incremental strategy where you can provide value much more quickly to the business makes a lot of sense as you're growing into a GDPS solution. On page 20, the configurations that we support today are active standby and active query. And I'll go into each of those here. On 21, when you look at an active standby solution, here we have Site 1 and Site 2, and this format is going to be repeated on a lot of these slides, so I'll just kind of explain it the first time. So on the left you have Site 1, on the right you have Site 2. You have connections coming into Workload Distributor, and right now, because Site 1 is active, you have all the workload going there and then data replication going to Site 2. Now both these sites are on, they're both up and running. The data replication is happening at a higher level than disk-based replication, like QRep. And so both of these are ready to go and ready to take transactions, but only one of them is actively working. If you then tab through and you see if workload A is no longer working, we're going to go ahead and route that workload's traffic to site 2 and then reverse the data replication direction. Now I want to note here, the site's still up and running. There's not a site level outage here. There's a problem with that workload. It could have been anything. Somebody could have fat fingered a command. There's many different things that could have caused an interruption in that workload. And so this is an advantage for targeting just a single workload, because we can limit the disruption to your organization. A full site switch is a really big deal, right? And we can limit the exposure and impact to your organization and still maintain high availability for your key workloads by just switching that workload over and having other workloads that are still working on the other system go ahead and continue operating on that system. The only caveat I'll make is that workloads need to be organized by the table groups or the data that they depend on, right? When we switch the data over, all the systems that depend on that data need to switch over. So data replication can be bidirectional between sites, but not for the same data. And we'll get into that a little bit more later. If you tab again, you see now the entire site went down. And we're going to continue to send the traffic to the secondary site, and we'll queue up the data replication request for that primary site until it comes back online. Scenario 2, starting on page 24. Now this one's interesting. We call it active standby, but both sites are actively running workloads at the same time and receiving traffic at the same time. The key differentiator being that it is 2 different workloads. So as you see, site 1 is the active site for workload A, and site 2 is the active site for workload B. And in this scenario, workload A and workload B can't depend on the same table groups or data. But if you have different workloads that are interacting with different table groups, this scenario can work really well. And so you can be fully loading both systems at the same time, or partially loading both systems at the same time, and they can provide failover for one another. So in this scenario, site 1 would be the standby for workload B, and site 2 would be the standby for workload A. This allows complete reliability and failover while not having a cold site sitting there not doing any work for you. This is one of the more interesting scenarios for our customers that really want to get value out of their second sites. So, active query. In short, what active query does is all of the read and all the write transactions are going to continue to go to your primary site. We can take those transactions that are read-only and send those transactions to the secondary site for the same workload. So again, because we don't want to have data conflicts and where's the most recent data, who had the most authoritative update if it's updated in both places, all data writes still go to a single site. But if you have a write seldom, read many kind of application workload, where most of your workload are reads, then this can work really well, where a lot of your query traffic can be sent to your secondary site, and some of your queries and all of your writes are sent to the primary site. So let's look at how that works. On page 26, what we're doing is we're using NetView to help track the data replication latency. So a lot of businesses will say, yeah, that's great. I'd love to get my secondary site active, and for my really important claim system, it can take off some of the load from the primary site for that claim system and take some of the traffic. But if my data is not fresh enough, then I need to make sure I'm getting accurate information. And so we have the ability for you to set SLAs for how stale your data can be. Is that 2 seconds? Is that 5 minutes? What makes sense for your business, that if the data is not that fresh or fresher, then you're going to go to the primary site regardless, right? So here we see a scenario on 26 where when the replication latency is normal, we're going to go ahead and route queries to both the primary and the secondary site based on load conditions. And as you see on 27, when that latency becomes acute, we cut the secondary site off, and we send all queries to the primary site to make sure that the data is accurate. And then when it goes back to normal on 28, we reinitiate the splitting of the transactions and send it to the secondary site again. And so that's a really powerful scenario for customers that they don't have the kind of workload distribution where they can even out the distribution of load on their sites by having workload A be on one side and workload B on the other. If they have a primary workload that they're really targeting, active query allows them to still get some value out of that secondary side and take on some of the load. What I will say about this is from a use case fit or compatibility perspective, you're looking for workloads where either the entire workload is read-only or it is easy for you to refactor the application or workload to be able to isolate what transactions make writes versus reads. So in other words, if you have an application making database updates, but it also does queries, you would have to have a different connection pool or IP address or domain name that you're targeting for the reads and the writes so that we, at the routing level, can determine what traffic is meant for the primary site and what traffic is meant for the secondary site. You don't need to target it directly to a site, but you do need to target, here's the IP for reads and here's the IP for writes so that we can route it appropriately. So that is active query. On page 29, we start looking at the physical architecture of the solution. So you can have your first tier and your second tier load balancers. First tier load balancers are going to be deciding what site to go to. Second tier load balancers are going to be routing traffic within that site. There's the primary and the backup controller at your primary and secondary site for a Lifeline asset, and they're going to talk to each other and make sure that there's resiliency and failover between those two. And then there's agents that reside within each of the Lifeline-enabled LPARs. So I think that the primary pieces of a Lifeline solution are composed of a agent living within the LPAR that is Lifeline-enabled, and the performance cost or latency of that agent is so small it's almost difficult to measure. I mean, we're talking extremely low impact to the performance and MIPS on that LPAR. Those agents then communicate to the Lifeline advisor, and that advisor then advises the F5 and tells it where to route traffic. So those are basically the main components that are keeping track of the health of all of your workloads, figuring out if it is completely dead or if it is under duress and something needs to happen in order to maintain the SLAs of that application. So starting on page 30, or on page 30, we see, I think what I just described actually covers most of this here, the physical architecture of what's happening for the Lifeline architecture. So starting on page 31, I want to talk about the use case that has actually been super impactful for our Lifeline customers, and that is not the typical case that you would think of for a DR strategy, which is what happens when things go haywire and there's an incident, something significantly wrong. But instead, what about when I need to do a Sysplex-wide upgrade or an application-level upgrade? And what kind of outage am I going to incur on a plan basis for my organization? Is there a way that I can reduce that? We have a lot of customers with strategies around reducing impact to customers and partners during plan outage scenarios. And Lifeline has proven to be super helpful in that use case. So when doing a Sysplex or application-wide upgrade, the requirements for Lifeline, or in order to help with that, are to distribute the workload between the sites based on customer-driven commands, and switch workloads from one site to another site, and maintain a workload configuration states in the event of a plan outage. And so basically what we're talking about is the ability to shut down active transactions on your primary site, wait for that workload to acquiesce, go ahead and for the replication queue to flush out, go ahead and switch traffic over to the secondary site and then be able to start taking transactions again right away. Do the upgrade to the primary site and then going through that same process in the reverse, coming back the other way. And so what this does is it cuts down, instead of you needing to go through everything I just talked about, shutting down the traffic, acquiescing the workload, and then doing all of the maintenance that you need to do, and then re-IPLing the system, and then being able to take transactions again. We cut that off right after the replication queue flush, and we can now start to take transactions right away. which dramatically reduces the time that many customers see during planned outages. And that is, unlike a DR scenario where you are buying into an insurance policy in case something happens, we all know this is going to happen. You are going to have planned outages, and this is a great way to reduce the pain of it. For this scenario, for the planned outage scenario, you actually don't need NetView. NetView is the only needed during active query. So the requirements for the planned outage scenario is just Lifeline and either QRep or InfoSphere data replication for DB2 if you're using IMS, InfoSphere IMS replication, and if you're using vSAM, InfoSphere vSAM replication. So whatever second level replication technology you need for your workload plus Lifeline is all you need. Starting on page 34, we see the way that would work with a graceful switch. Right now we have everything going to site 1. We're going to go ahead and stop new connections, and then wait for the application acquiesce, start sending client connections to the distributed site 2, and then when the workload's done, then we're going to send everything back and be replicating back to the primary site.